Welcome, everyone. My name is Brittany Todd, and I'm a member of the Fabric Leadership Team. Thank you all for joining us today for the Stitching Together Innovation with Fabric Users webinar featuring Benjamin Formby. Next slide, please. Before we begin, I would like to share a few housekeeping items. The webinar will include a live question and answer session following the presentation. Please note that the chat feature has been disabled. If at any point you have a question, please type it into the Q&A box at the bottom of your screen, and we'll answer it during the Q&A session. Last, this webinar is being recorded and will be shared with all registrants. Next slide, please. We are joined today by our presenter, Benjamin Formby. Benjamin is a PhD student at Clemson University with a research focus in AI and machine learning for medical imaging. He uses Fabric to create end-to-end experiments, implementing his AI applications in realistic network simulations. He has also been a part of the Fabric student group for 2 years now, assisting with user support for the Testbed. I will now pass to Benjamin to start the presentation.
Thank you for the introduction. Here's the agenda for today. I'll start with an overview of AI and machine learning and some popular research topics going on today. And then I will talk about our research at Clemson University, where we specialize in machine learning for medical imaging. And then I will go through what resources Fabric has to offer for AI and machine learning research and how we use Fabric for our research. I'll talk about how to get started with Fabric, and then I will go through a Jupyter Notebook tutorial on how to reserve some of these resources on Fabric. I will end with a live demo of the experiment that we're running at Clemson University with the medical imaging application of AI. And so to get started with some applications of AI and machine learning, AI doesn't need much of an introduction, I don't think, but there's many applications of computer vision that we see in our day-to-day lives, whether it's on our smartphones or smart devices, and self-driving cars. We see applications of object detection and image recognition. We see face detection and face recognition. There's also natural language processing methods being used, including speech recognition and language translation. We see these popularly now with large language models and chatbots. And then also there's privacy and security applications of AI with network security, and also, again, with things like face recognition. I'm sure we've all seen in media the hype about generative AI recently with applications like text-to-image generation with OpenAI's DALL-E, where you give it a prompt, and it can be something like a teddy bear swimming at the Olympics, like you see over here in this picture on the right. And these models are able to generate images based on text. They're able to summarize text. We see applications of image or music style transfer, and then also applications like image captioning. And next, we see AI in healthcare. A lot of applications in healthcare today include computer-aided diagnosis. There's pathology detection and injury detection, where doctors are using models to help identify diseases or injuries like bone fractures and things of that sort. There's also more specific applications like segmentation methods for segmenting injuries or brain tumors in medical imaging. And then there are also applications like feature enhancement or image quality assessment to help the interpretability of medical imaging data. And so this brings me to the research that we are doing at Clemson University, which is AI for medical imaging. We specialize in ultrasound imaging because of its growth and popularity more recently, and its relative inexpensiveness along with the accessibility. Some of the machine learning tasks that we look at are muscle pain measurement and tendon injury assessment. And so when we run experiments, we like to do end-to-end system design, where we start at the source, collecting live, raw ultrasound data from an ultrasound machine. We can stream that data and process that data so that we can ideally provide real-time feedback to the ultrasound operator. And so with our experiments comes a few research needs, and that includes a sandbox where we need to simulate our end-to-end systems. We also need hardware resources for both the computing side and the network side. And then also, given the multidisciplinary characteristics of our team, we want something that is easy to use and easy to configure. And so that brings me to why we chose Fabric. The Fabric provides a lot of resources, both computing and networking. Fabric has CPU cores, GPUs, FPGAs, persistent storage, all for computing. And then for the network resources, they provide a controllable and programmable network infrastructure. They also provide facility ports that is used for connecting Fabric to other test beds or other services. For example, the Chameleon testbed or Cloud Lab. And you can also use these facility ports to connect a campus machine. Like at Clemson, we're able to connect our ultrasound machine into the Fabric infrastructure. And then last but not least, Fabric has high bandwidth links between all the sites across the United States and even the globe. You can see in this map, this shows all the sites that make up Fabric's infrastructure. All the blue links are 100 gigabit links, and then there's also 2 yellow links, which are the 1 terabit links. And then when you hover over any of these sites, you can see in the Fabric portal, you can see all of the available resources, whether it's the cores, the storage, RAM, GPU, etc. And so since this is a AI and machine learning webinar, I'm sure we're all very interested in the GPUs that Fabric has to offer. And so here is a table of the GPUs that Fabric has. There are 4 options, all NVIDIA GPUs consisting of the Tesla T4, RTX 6000, A30, and A40. And here is a table of some of the specs, depending on what your experiment may need. You can choose from any of these 4. And then in the Fabric Portal website, when you hover over a site, you can click on the site to get more details about the resources and the GPUs, specific models that are available there. And so getting started with Fabric is really easy. When you go to the Fabric Portal website, you go to the Sign Up tab in the top right corner and then follow the steps that are outlined there. Once you have an account set up, you will need to join a project. And you can join a project through one of 2 ways. You can either contact a project lead who you may already know, ask them to add you to their project, or you will need to ask your professor or advisor to request for a project for your research team. And once you have an account and once you are a part of a project, you can start experimenting. And so Fabric provides a really easy to use Jupyter Hub, which you can access through the convenience of your browser. And then Fabric has the FabLib API, which is accompanied with plenty of documentation on how to use it. And then additionally, Fabric has a lot of Jupyter Notebook tutorials, which kind of give you all of the building blocks and foundation that you may need to run your experiment. And so now I will walk through a Jupyter Notebook tutorial on how to reserve a GPU on Fabric. And so this tutorial is, again, part of the Jupyter Hub that Fabric has, where you can access through the Fabric Portal website. So you'll go to the Jupyter Hub tab at the website. And then once you have your Jupyter Hub open and running, you can navigate to the latest release of the Jupyter Examples folder. And then you're going to want to open the Start Here notebook. And this Start Here notebook will be your best friend when getting started with Fabric. It has all the tutorials that you'll need for getting started and learning how to build your experiment. And so within this notebook, you're going to go down to the Fabric GPU example notebook. And so this notebook is broken up into three main sections, with the first being reserving your resources, and then second being installing all of the dependencies, and then finally running the experiment. And this is the general structure for most of the notebooks that you'll find on the Start Here page, and should probably be the general structure for your experiments as well for easy reproducibility. And so first, when you're reserving resources, you'll choose your GPU, and then when you're installing dependencies, you'll need to install things like the GPU drivers, CUDA, PyTorch, and upload any code that you may have for your experiment, and then finally run the experiment. And so more specifically, for reserving resources, when you choose a GPU model, there will be 4 choices. So you're going to make that choice, and then you will create a new phablet or fabric slice with slice equals phablib.newSlice. You'll give it a name, and then you'll add a node to that slice, and that node is where you'll choose a site and how much storage you want, any image that you may want. So here, this node has a default Ubuntu 22 image, and then you'll add the GPU to this node, and this is where you'll specify the GPU model. Now, when choosing a site, you want to ensure that the GPU model that you chose is available at that site. Now, once you have your slice with your node and your GPU, this example will submit the slice reservation, and your slice will be reserved in just a few minutes, and you'll know that it is fully reserved and ready to go when you see the green stable OK pop up. And so once that slice is ready and available for you to use, you can query all the details about your slice, all the node details and the GPU details. And then also you can view your slice in the slice viewer on the Fabric Portal website. And that's what this looks like in this figure in the top right. And so next in the example, you're going to want to install all of the dependencies. And so again, that includes things like the drivers, the CUDA, PyTorch. There's 2 scripts in this example that you'll need to upload. And then there's no data in this example, but for your experiment, you may need to upload data. And so this is done as easy as having node.execute whatever command. And so you can install all of your dependencies that way. And then for uploading scripts or data, you can use node.uploadFile and upload files that way. And lastly, you run the experiment. And so for this example, there are 2 parts. In the first part, the notebook follows a tutorial given on NVIDIA's documentation, where you compile and run some CUDA code, and it prints hello world using the GPU that you just reserved on Fabric. And then the second part of this experiment is training an image classifier using PyTorch. And this tutorial is taken from a tutorial in the documentation for PyTorch. And this model gets only 51% accuracy, so hopefully you can do a lot better. And so now I will walk through the experiment that we've been working on at Clemson, where we're looking at real-time feedback for live ultrasound imaging. And so for this demo, quick motivation is that ultrasound, again, is growing in popularity and accessibility, and ultrasound technicians could benefit from real-time feedback during their imaging. And so this could be computer-aided diagnosis, or it could be some image quality assessment, any kind of feedback to help the technician during the imaging process. And so goals for this demo is we want to provide real-time machine learning predictions to aid diagnosis for Achilles tendon injury. And then we want to be able to process images at a remote compute node to relieve the computational needs at the source. And so setup for our demo is we have two nodes. We have a source node and a compute node. And then we have a GPU that will reside at the compute node. And then we have a facility port, which we use at the source node to connect to our campus ultrasound machine. And then lastly, for setup, we'll install dependencies like PyTorch on the compute node and streaming services on the source node. And then we'll be able to run our experiment. We will stream live ultrasound video to the compute node. We'll process frames at the compute node and make machine learning predictions on each of those incoming frames. And then we will send back predictions as real-time feedback. And so here's the topology, again, using the slice viewer that is on the Fabric Portal website. And so you can see on the right is our Clemson node or our stream node, and that is connected to the facility port connecting the ultrasound machine. And then our stream node is connected to the compute node located at the STAR site in Chicago with the GPU. So now for the live demo, I've recorded here. So by now you've heard an introduction to how to use Fabric for AI and machine learning research, and you should have seen a tutorial on how to reserve a GPU on Fabric. And so now I will walk through this simplified version of the experiment that we are doing here at Clemson University, where we are live streaming ultrasound video and making real-time machine learning predictions so that we can give real-time feedback to the ultrasound technician or operator. So the first thing we do in this notebook is import the FabLib library, and then we can print the configuration here to see important details like the version that we're using or the project that we're currently using. Next in this cell is how we create our experiment slice. And so at the top, we're specifying different names like the slice name, what facility port we're using, and our node names. And so as I previously described, the topology for this experiment has two nodes, with the first node being the source node, which is attached to the facility port, and then the second node being the compute node. And so we create our slice using fablib.newSlice, and we give it a name. And then to add our first node, we use slice.addNode and give our node a name, and then tell what site we want. And so we're using Clemson for our source node, and then how much disk space we need. We're using 100 gigabytes, and then the image that we want. And so for this, we're using a default Ubuntu 22 image. Then on our source node, we need to add two interfaces or network interface cards. And so the first interface we add is for the facility port so that we can connect to the facility port. And then the second interface is for connecting to the compute node. Next, for node 2, we have slice.addNode and give node 2 a name, which is the compute node. And we're reserving this slice or this node at STAR in Chicago with disk space of 200 gigabytes and the same default Ubuntu 22 image. This node only needs one interface to connect to the source node, and then this node will have the GPU component. So we have node2.addComponent and specify the model of the GPU we want, which in this case will be GPU Tesla T4, and then we can give that a name as well. Next is the facility port. So we have slice.addFacilityPort, and we specify the name of the facility port, the site that it's at, and the VLAN that we're using. And so we're using VLAN port 4000. And lastly, for setting up our topology, we set up the network connections. And so for the first network, we have an L2 network that I'm naming net facility port because this is the connection between node 1, the source node, and our facility port, which is the ultrasound machine. Then network 2 is another L2 network, and I named this net stream because this is the network that node 1 will be streaming to node 2 on. And lastly, we submit our slice request. So after we wait for our resources to be reserved, we'll eventually see that our slice enters the stable OK state. And then we will be able to see all the details about our slice, including details about our nodes. You can see here our compute node and our stream node, how many cores, how much RAM, the disk space that it has, and also the SSH command, a lot of details that we may need. And then we can also look at the networks that we set up and the interfaces. So once we have our topology set up, we can also view this in the slice viewer on the Fabric Portal website. And to do this, we'll go to the Experiments tab. Once you're logged in, we'll go to My Slices. And then here is the slice that I just set up. We have the Clemson site with our stream node and ultrasound facility port. And then this is connected to our star node, compute node with our GPU. Now back to the notebook. The next step in this notebook is to set up and install all of the dependencies that we need. And so I'll skip over these next few cells. This is ensuring that our nodes are connected and the interfaces are set up correctly. And then these few cells are setting up the stream service on our stream node, node 1. Now we install the dependencies for our compute node. And the first thing that I do here in this notebook is upload the PyTorch Python script that we use in a PyTorch model that we pre-trained for this experiment. And so what this script does is it reads in the frames that are being sent from node 1 and makes a prediction using this model whether the tendon is healthy or unhealthy. And so we upload those files and then we install the drivers for the GPU. After we do this, we need to reboot this VM so that the changes can take effect. And then here we can use these commands to see that our machine does recognize the GPU and that it's able to use it. And now we are installing all of the packages needed for our script and for our experiment. And so finally, we can run our experiment. This is ensuring that our two nodes are connected with a simple ping test. And then finally, to run our script, we can either do that through this Jupyter notebook, or we can SSH into our nodes. And I will be doing it manually through the terminals logged into each node. And so here in these two terminals are our nodes 1 and 2, stream node and compute node. Now, if we look at the interfaces on the stream node, we can see, we can first see the management interface, which is how we connect to our VM. And then we can see one interface for, we can see one interface for the facility port and one interface for the compute node. Now, when we do the same for the compute node, we only see two interfaces. One was the management plane interface, which allows us to connect to our node. And then the other interface is connected to our stream node. So now I will get ready for the live demo. So for this demo, I am here in our ultrasound machine lab at Clemson University, and I'll be scanning my own Achilles tendon and streaming that ultrasound video to our compute node, which will make predictions on whether or not my Achilles tendon is a healthy tendon or not. And so on the right side of my screen is OBS, which is the software allowing me to, I can connect the ultrasound machine to my computer, and then my computer is connected to the port used for the facility port connecting to Fabric. So now on the right side of the screen, you should see this is me looking at my own Achilles tendon. I'll try to get a good view. And then I'll start streaming. And so now on our compute node, I will run the script to start making predictions. And so you can see the model is making predictions. So far, all healthy, which is a good sign for me. You can see occasionally if we have a bad quality scan, it will pop up unhealthy. And now we've reached the end of this notebook. It's always good to delete your slice once you're done with your experiment so that other users can reserve the resources that you were using. And so now that we have a basic setup for streaming live ultrasound video and making predictions on that video, we can take this experiment a lot further and look into areas such as scalability, where you can imagine multiple stream nodes, where there may be multiple sites with ultrasound machines that need video to be processed and predictions to be made. And so we can look deeper into that, the scalability problem, try to figure out where this experiment may bottleneck, whether it's in the network or whether it's the processing, and look into different solutions like certain pre-processing solutions that could be done at the source, or maybe other solutions that could be done on the compute node. And so that concludes this live demo. Thank you. And so in conclusion, Fabric provides many resources for getting started, and it's really easy to set up. And some of the resources includes materials like example notebooks and that give you all the details on how to learn the basics for setting up your experiment. And then also there's plenty of documentation available for how to use like the FabLib API. And then Fabric also has a really active community. So between the forums and the webinars like this one, and then also workshops that happen at least, I think, twice a year, the community is very active and very helpful. And Fabric is also very well equipped for our research needs as both AI researchers and networking researchers. They provide really easy experiment configurability, and also they provide all of the hardware resources that we may need for both computing and networking. So thank you.
Thank you so much. We really appreciate it, Benjamin. Now we're going to go and move into the question and answer portion of today's webinar. The first question we have is, can a reserved GPU support multiple users?
So yes, I think that comes down to being able to um, share a slice between multiple users, and you are able to have multiple users access a slice. And so within that slice, or within your experiment, is where that GPU is reserved, and anyone who has access to that slice can use that GPU.
Great, thank you. Who can get access to Fabric?
Um, I guess anybody. You sign up with typically with your institution, um, and then you can get an account that way, but then you'll need to join a project. And so, um, like I said earlier, to join a project, you'll need to ask someone who is a project lead, or you can ask an advisor or a professor, or if you are a professor or advisor, then you can fill out a form to request for a project.
Great, thank you. What is the most challenging aspect, do you think, when a new user trying to get an ML project working on Fabric?
Could you say that again?
Yeah, I'm reading it verbatim. Let me see if I can shift it a little bit. So, what do you think is the most challenging aspect for a new user trying to get machine learning project working on Fabric?
Um, I guess if you are an AI researcher, maybe the most challenging part would be just getting used to setting up, uh, like using the FabLab API to set up a topology and reserve the resources. I think once you have a slice running, it's um, pretty easy to interact with the resources that you have.
Okay, great. Thank you. Let me see, how do I upload my training data to my Fabric slice?
Yeah, so it's a good question. There's a few different ways you can do that. Um, the first and maybe easiest way would be if your data is small enough, you could potentially drag and drop just in the Jupyter Hub, and then you can upload from the Jupyter Hub all of that data to your nodes. And then, however, if your data is too large for that, you could um, just use SCP file transfer. So very similarly to how you would SSH and connect to your nodes, you could use SCP to transfer your data to your nodes. And then um, there's also persistent storage, which you can request for so that you don't have to upload data every time you run a new experiment, because the storage that is on your slice or on your experiment lasts only as long as your slice. And so Fabric slices, I think, default to 2 days, and you can extend that lease, that reservation for longer than that. But you can also request for persistent storage, and that allows you to kind of get around having to upload data over and over.
Great, thank you. Can you share any experience with training a deep neural network on Fabric? Many thanks.
Um, yeah, so it's really not any different than if you were to train a model um, like off of Fabric. Like once you have the reservation and you have that GPU, then um, I guess the hardest part would be to upload the data to your node. But once you have all of that set up, um, it's pretty, I think, straightforward from there. It'd be like if you're using a GPU on your own computer, or uh, yeah.
Thank you. Next question. I could not see details in your slices. On the demo, there was a slide which I could not understand well. It was the video and streaming results. Could you expand?
Um, could you could you repeat that?
Yes. I could not see details in your slices. On the demo, there was a slide which I could not understand well. It was the video and streaming results. Could you
Okay.
expand?
Yeah, so in the demo, all that was happening was I was running a script that had a pre-trained model that I had uploaded. And um, and so that script was using the pre-trained model to uh, read incoming frames and make a prediction for every frame. And so in the demo, I just had it print healthy or unhealthy in the terminal um, for that prediction. If there's something more specific, I can always try to answer uh, better if I didn't answer your question.
Thank you. Next question. Why do we need two nodes in the slice? Do we need two nodes for every ML experiment?
No, um, it all depends on what kind of experiment you want to run. If you just need a GPU, then you can just have one single node, and that's actually what is done on the tutorial notebook in the start here. So yes, you can just have one node with one GPU. In my demo, we had two nodes because we were trying to simulate if there was a site that had an ultrasound machine, but there was no like heavy computational resources available, then we can stream the data to like a remote processing, uh, maybe data center. And so kind of this idea of, like I mentioned with the future directions, we can look at scalability with many streaming nodes and all streaming to one central processing node. But it all depends on what you want to research and what your experiment is.
Great. Next question. What is the advantage of running AI ML on Fabric versus running on general HPC?
I think so for us, as I mentioned, our end-to-end system design, it makes it really you can't really simulate kind of real world or realistic scenarios with just a high performance computing center. With Fabric, you can set up topologies like in the demo with um, where you can simulate different um, like sites at completely different ends of the United States and simulate all kinds of distributed setups like that. I hope that
Thank you.
answers that question.
Sure. So the next question is, what's the difference between the storage on my slice and persistent storage? How do I get persistent storage?
Yeah, so the storage on your slice is it's going to expire with your slice, and the persistent storage you have to request for. But once you have persistent storage, you uh, it's persistent, so you can just access it and not have to re-upload data every time you create a new slice.
Thank you. All right, so then the next question is, what if Fabric doesn't have enough GPUs for my needs? How many GPUs does Fabric have?
So I think Fabric, that's a good question. Fabric, I think has most sites have anywhere from 2 to 10 GPUs. And so I don't believe there's a limit to how many you can request, at least right now. Um, But if that isn't enough, you can use facility ports to use other test beds or other uh, external facilities like Chameleon Testbed, which has a lot of bare metal resources. So you can uh, connect to external facilities like that if you need more specific computational needs.
Thank you. Next question, do I need any special permissions to use the GPUs or facility ports?
Yes. So you need permissions for both. And the project lead that uh, whoever's leading the project that you're a part of will need to request for those permissions.
Great. And I think this might be our last question, unless another one comes in, but is it okay to upload HIPAA data to Fabric?
Uh, so no, unless you can anonymize it enough, but not necessarily. You need to make sure that um, it's not the privacy isn't, I guess, guaranteed. So just to be safe, you would need to make sure that all of the data that you're using on Fabric is anonymous. Um, so like no sensitive data.
Thank you. And
Yeah.
thank you again to our speaker, Benjamin Formby, that has concluded our question and answer session as part of this webinar. In addition to our presenter, we would like to acknowledge the behind the scenes team listed here who worked diligently to bring this webinar to production. Next slide, please. I also want to thank you, the audience, for your participation in today's webinar. In addition to a recording of this webinar, we will also email everyone who has registered a list of resources. This slide deck will be shared along with a link to our Slack channel and Connect with Us form. We hope that you will reach out to the Fabric team for questions or support. Next month, we have 2 webinars. The first is Stitching Together Innovation with Fabric Users on Tuesday, October 21st at 3 p.m. Eastern. And the second is Mastering Fabric, Tips and Tricks webinar series on Monday, October 22nd at 2 p.m. Eastern. The October 22nd webinar is geared towards existing users, and the October 21st webinar is geared towards new users. So we would appreciate it if you could forward the information to the relevant users in your communities. As a final reminder, please submit your Fabric matrix and make sure your project abstracts in the portal is up to date, as we will use that information for outreach, including our website. Thank you again and have a wonderful day, everyone.